Hello, our today's lecture is called Essential or Volatile Oils, and this is the second lecture for Year 3 pharmacy students on pharmacognosy. And I am the PhD of Pharmacognosy Department, Azerbaijani Medical University, Huraman Mustafaeva. So let me present you the plan of our today's presentation. First of all, we will discuss few definitions for essential oils to understand what class of compounds we're talking about. Then we'll give information about distribution, localization, and function of essential oils in a plants, their physical properties, chemical composition, of course, biogenesis, different chemotypes of essential oils, procedures of production of essential oils. I will be covering the quality control of essential oils, their pharmacological properties and use, and to finish, I'll give you some information about a few plants containing essential oils. So to start with the definition, I would like to say that there are several definitions for this class of compounds, but not all of them are complete. So here I chose three of them and would like to present you. So the first one says essential oil is a product obtained from a natural raw material of plant origin by steam distillation, by mechanical processes from the epicarp of citrus fruits, or by dry distillation after separation of the aqueous phase. So this one is I would say more like a definition by production of essential oil, and it is a little bit restrictive. It doesn't give, for example, the information about the other methods of extraction of essential oils. So the second one by Birch-Bauer from 1994 says essential oils are more or less volatile substances with more or less odorous impact produced either by steam distillation or dry distillation or by means of mechanical treatment from a single species. So here we have more information about their physical qualities. And the third one, which is most recent by France and Novak, says essential oils are complex mixtures of volatile compounds produced by living organisms and isolated by physical means only. Pressing and distillation from a whole plant or plant part of known taxonomical origin. So this one also, this definition is also excluding the products obtained by solvent extraction, for example, as well as those obtained by any other processes, pressured gas, enfleurage, and others. Yet these other processes supply a large part of the following industrial markets like pharmaceutical, hygiene products, cosmetic, perfumes, and others. Therefore, we find it useful to first define the terms most commonly used in this field. So, what can be obtained from the plant material depending on the process of production. Concretes are extracts of characteristic odor obtained from a fresh starting material of vegetable origin by extraction with non-aqueous solvent. Concretes. The pomade. Pomade is perfumed fat obtained from flowers either by cold enfleurage, it means diffusion of the odoriferous constituents of the flowers into the fat, or by hot enfleurage. Resinoids are extracts of characteristic odor obtained from a dried starting material of natural origin by extraction with a non-aqueous solvent, so most probably organic solvent. Here, starting material of natural origin means of a vegetal, animal, or microbiological origin, including products derived from these starting materials by enzymatic routes. Absolute product of characteristic odor obtained from a concrete pomade or resinoid by ethanol extraction at ambient temperature. The resulting ethanol solution is generally cooled and filtered in order to eliminate waxes. The ethanol is then removed by distillation. So here are some definitions that are corresponding to these types of products. For distribution of essential oils. Essential oils occur virtually only in higher plants. According to Lawrence, there are 70,500 aromatic species. The genera capable of elaborating these compounds that constitute essential oils are distributed in a limited number of families, for example, Myrtaceae, Brutaceae, Asteraceae, Lauraceae, Lamiaceae, Poaceae, Zingiberaceae, etc. Essential oils accumulate in all of the types of vegetable organs. Flowers, of course, like for a bergamot tree, for example, but also leaves, like in eucalyptus or laurel, and although it is less common in barks for cinnamon, for example, woods, like in rose and sandalwoods, roots for vetiver, rhizomes for turmeric and ginger, fruits like anise and star anise, and seeds like in the case of nutmeg. All of the organs of given species may contain an essential oil, but the composition of this oil may vary with the localization. For example, in the case of a bitter orange tree, Citrus aurantium, the zest, that is the fresh pericarp of the fruit, is used to produce bitter orange oil, or essence de bigarade. The flower is used to produce neroli oil, or orange flower essential oil, and steam distillation of leaves, twigs, and small fruits produces petit grain oil. These three essential oils have different composition. Quantitatively, the levels of essential oils are rather low, and quite often they are lower than 10 milliliter by kilogram. High levels, such as those of the flower bud of the clove, approximately 150 milliliter by kilogram and more, are exceptional. The synthesis and accumulation of essential oils are generally associated with the presence of specialized histological structures, often located on or near the surface of the plant. Oil cells of Lauraceae or Zingiberaceae plants, glandular trichomes of the Lamiaceae, secretory cavities of the Myrtaceae or Rutaceae, and secretory canals of the Apiaceae and Asteraceae plants. In most cases, the biological function of the terpenoids of essential oils remain obscure. It is conceivable that they have an ecological role. This hypothesis is supported by experiments which prove the role of some terpenoids in plant interaction, like allelopathic agents, particularly germination inhibitors, as well as in plant-animal interaction, protection against predators like insects and fungi, and attraction of pollinating species. For some authors, the terpenoids might support some sort of communication, especially since their structural variety allows for the transfer of selective biological messages. So now on this slide, I'll show you some physical properties of essential oils. So essential oils are liquids at ambient temperature, means at room temperature, but they're also volatile, which is what differentiates them from fixed or fatty oils. They are only very rarely colored, so they're uncolored. Their density is generally lower than that of the water, but with some exceptions. Generally, if we have if we mix the water and essential oil in a decanting flask, we'll have the essential oil which is lighter than water on the top and water on the bottom. But in the case of essential oils like clove and cinnamon, their density is lower than the water's density, so they appear on the bottom of the mixture, and here this is the way of separate them from the water actually. So essential oils have a high refractive index, and most of them rotate the plane of polarized light. They are soluble in common organic solvents and in fats. They're liposoluble. They can be steam distilled and are sparingly soluble in water. They are water soluble enough, however, to impact a distinct fragrance to water. Here how we obtain aromatic waters. So they give, with mixing with water, they give their aroma to the water. Essential oils are complex and highly variable mixtures of constituents, which belong virtually exclusively to two main groups with a distinct biogenetic origin: the group of terpenoids and the group of less common group of aromatic compounds derived from phenylpropane. Some essential oils contain degradation products of non-volatile constituents. So to start with terpenoids, essential oils contain only the most volatile from terpenoids. It's, in other words, monoterpenes and sesquiterpenes. Monoterpenes, the hydrocarbons are almost always present in monoterpenes. They may be acyclic, and here we have the example of cyclic alcohol monoterpenes like linalool from lavandula and geraniol from rose petals, and they could be aldehydes like in the case of citral from melissa. Monocyclic monoterpenes is a second group of monoterpenes. They could be hydrocarbons like limonen, alcohols like menthol, ketones like menthone and carvone from spearmint, and ether oxides like in the case of eucalyptol, peroxides like ascaridol, and phenols like thymol. And the third group, the last monoterpene group, is bicyclic monoterpenes, and with examples of hydrocarbons like pinene, alpha and beta pinenes, sabinen, alcohols like borneol, and ketones like camphor and thuol. The second group of terpenes, the constituents of essential oils, are sesquiterpenes, which consist of 15 atoms of carbon, and they also divided into three groups like acyclic, monocyclic, and bicyclic, like the same way like monoterpenes. Structural variation in this series are of the same nature as in the monoterpenes, with hydrocarbons, alcohols, and ketones being the most common. It is noteworthy that the elongation of the chain increases the number of possibilities of cyclization. Hence, the very large variety of known structures. Over 100 different skeletons have been described. Examples are farnesol, humulen, cadinen, and others. Phenylpropanoids are far less common than terpenoids, or in other words, aromatic compounds. They're less common, but they still exist, and very often they are allyl and propanyl phenols, excuse me, and sometimes they're aldehydes, characteristic of certain apiaceae oils like anise, fennel, parsley, and others. But also they could be found in the case of clove, nutmeg, tarragon, sweet basil, and other essential oils. Also found in essential oils C6, C1 compounds such as vanillin or methyl anthranilate. So here you see the examples in your slide with structure of cinnamic aldehyde, eugenol, anethol, and anisic aldehyde. So here I would like to explain your head-to-tail coupling of isoprene units. So how it's happened, it's also called prenylation reaction. Here we have the condensation of DMAPP with isoprenyl pyrophosphate. The same prenylation reaction, this prenylation reaction gives us geranyl pyrophosphate molecule, which consists of 10 carbon units. The subsequent addition of another IPP consisting of C5 give us farnesyl pyrophosphate, which consists of 15 carbon molecules, and give the beginning for sesquiterpenes, and another addition of IPP unit with 5 carbon atoms give us the geranyl pyrophosphate. So this reaction continues, and each time we add another C5 molecule of IPP, so the geranyl pyrophosphate or diphosphate, giving a beginning to the monoterpenes. It consists of 10 carbon atoms. Another addition of IPP gives us farnesyl pyrophosphate, which gives beginning to steroids and sesquiterpenes. Another addition of IPP gives us geranyl pyrophosphate. So it consists of 20 carbon atoms. So it is the precursor for D-terpenes. So now here on this slide, let us talk about formation of monoterpenes, different monoterpenes like acyclic, monocyclic, and bicyclic monoterpenes. Now, like we said before, geranyl pyrophosphate is a precursor for these molecules, and here we can observe the formation of geranyl cation, which forms acyclics like linalool. In the same way, we can observe the formation of another cation, which is neryl cation. And neryl cation can give the molecules like monocyclic monoterpenes like menthol and terpenol. And the other cation which participates in this reaction is terpenyl cation, so-called terpenyl cation, which gives the beginning of bicyclic monoterpenes. Okay, so bicyclic monoterpenes like borneol, camphene, pinene, etc. Here we can observe the formation of the liaison between 6th and 2nd atom, and here the between 7th and 2nd atom of carbon. Formation of sesquiterpenes are possible thanks to farnesyl pyrophosphate. Farnesyl pyrophosphate can give different sesquiterpenes, which consist all of 15 carbon atoms. It could be cyclic or linear sesquiterpenes, monocyclic sesquiterpenes like zingiberin, bicyclic sesquiterpenes like hamazolin, and etc. So I would like to go back to this slide to have a look a little bit on biosynthesis of phenylpropanoids, the aromatic compounds that make the part of essential oil. So if we have this schema here to obtain bimevalonic and pyruvate ways, the monoterpenes and sesquiterpenes like cymin, limonin, etc., farnesin, etc. So the other way, which is called shikimate way, is considered like the way of biogenesis of phenylpropanoids, with the examples of eugenol, havicol, and etc. So this is all for biosynthesis. Now, let's give you some information about chemotypes of essential oils, different chemotypes of essential oils. So what's chemotype? Chemotypes referred as a chemical breeds and are very common among plants containing essential oils. One, I can give you here the example of Thanacetum vulgare plant, now which is morphologically homogeneous, with the tansy, which is growing in different regions, morphologically absolutely homogeneous plant, but chemically it has 7 different chemotypes. So that chemotypes that contains myrtenol like a main compound, the chemotype with thuion like a main compound, artemisia ketone type, cineol type, camphor type, or other chemotype of tansy. So the same plant, depending on environmental factors, can have absolutely different chemical composition of the essential oil. So what are those factors influencing the constitution of essential oils? This can be location, geographical location of the plant, topography, and soil, etc., the climate in which the plant grows. Is it a hot region? Is it a humid region? The temperature, the UV radiation, etc. The soil type can influence, like pH of the soil and water holding qualities of the soil. Also, the period and method of harvesting, of course, method of extraction of essential oil, time of extraction, and length of extraction can influence the quality of an essential oil. Genetic material also plays a role, like the physiology and propagation characteristic of the plant, and also agronomic practices like fertilizers, irrigation of the soils, weed pest control, and the density of the plants growing in that specific area. So now let's come to the extraction or production, how we call it, of essential oils. So first, the most used way of production of essential oils is distillation method. Simple steam distillation consists in immersing the plant material to be treated directly in a still filled with water, which is then brought to a boil, like you can see here. So this is boiling water. The vapors are condensed. So the vapor come here, get in contact with the plant, and then the oil from the plant also evaporates and mixing with water vapor, and then they come to the refrigerator and are condensed in a cold surface, and then we can separate essential oil from the water based on the difference of density. Yeah? As we said before earlier, the density of essential oil and water can differ, so they not mix with each other, and they can just produce two different layers which are separated from each other by using this type of flask, which is called Ginsburg flask. And this Ginsburg flask is located in a big flask and allow us to separate essential oil from water. So here is another schema for distillation. So another way of distillation is called steam distillation, water distillation, hydrodistillation. And this kind of apparatus is used for hydrodistillation. So here's the process is the same, except the not steam gets in contact with the plant, but water itself gets in contact with the plant and boiling together, and then we also separate water from the essential oil. Here we have the pictures of the old manufacturing, and this method is used for a long time. Another methods which are used also to produce essential oils are solvent extraction. It can be either maceration method, so the plant material gets in contact with the solvent, and we leave it in the contact for some period of time, and then we filtrate, and this is how we obtain our oil and solvent mixture, and then the solvent could be evaporated to obtain the pure oil. And the continuous extraction is also could be used. Here you have the schema and apparatus for this. This process happens accompanied by heating of the solvent here down, which can be evaporated and get in contact with the plant. And then, of course, the residue of solvent is eliminated from the oil. Expression method is used for the citrus fruits, for example, like they have pericarps, and which contain the oil cells, and here we can show you the three types of expression, which the first one is sponge method, which is just uses the sponge to absorb the oil, and then the oil is extracted from the sponge. Another method is écueil à piquer method. We use this kind of apparatus which picks the pericarp of citrus fruits and allows oil to be extracted, expressed, in other words, and this is expression by, and this is a normal expression of rasping. These methods utilize high mechanical pressure to squeeze oil from citrus fruits. Another method of production oil is called by its French name enfleurage. Enfleurage is used mostly for the flower or flower petals of plants containing essential oils. In this method, the glass plate is covered with a thin coating of especially prepared and odorless fat. The freshly cut flowers are individually laid onto the fat, which in time becomes saturated. So this method allows us to use the liposolubility of essential oils. So they're dissolved in a fat, and when the fat is saturated with essential oil, it is extracted from the fat. Eventually, the fragrance saturated fat, known as, is also called a pomade, may be treated with alcohol to extract the oil from the fat. The uses of essential oils. First of all, of course, pharmacy. Essential oils are used in pharmacy. The vast majority of drugs are used crude, especially for preparation of infusions, like in the case of mint and balm and vervain and orange blossoms, and under the form of simple galenics. They are also used to prepare essential oils, some of which may have a therapeutic interest, particularly as external antiseptics. But the major part of which are designed to be aromatization of medication for the oral route. Essential oils are also the underpinning of specific therapy, which is called aromatherapy. Okay, they are used in aromatherapy. There are several use of essential oils. Like you can see on the slide, they can be used as diffusion with the special diffusers during the massage through the skin. We can inhale them. They can use topically and in the bath. But using the essential oil per oz is not recommended, as they can be very toxic. In perfumery, this is the main outlet, in fact, for essential oils, concretes, and absolutes, and resinoids obtained from the drugs. Cosmetology and the hygiene products industry are also consumers, even though the cost of natural products is often high and leads to the selection for mass production of synthetic alternatives. On the border between pharmacy and hygiene products, note the presence of essential oils in bath products, like for relaxing baths, etc. Like here you can see on this slide, also the essential oils are used in food and beverage technology. Some drugs are used raw, like herbs or spices. You can see in these pictures, and the others are used as essential oils or resinoids or oleresinoids, dispersed, encapsulated, or complexed. Although they are used to mask or to give the flavor to the food, right? Or to mask the bad flavor and aroma of the food. All the sectors of the food and technology are consumers, like alcoholic and non-alcoholic beverages, confectionery, dairy products. You can see here all the meat products like sausages, etc., and soups and snacks, bakery products, and of course the animal food. And since 1980, the use of natural food flavorings has been growing. Despite their expensive price comparing to synthetic ones, they're still very popular, as they give this natural impression to the products. Also, of course, they are used in household products and chemicals, and like we said in perfumery, like to make the fine fragrances. Here, I will give you the example of the plant, which is called lemon myrtle, or the Latin name is Bacusia citrodora. And you can see on the example of this plant, the dried leaf of the plant can be used like herbal tea or food flavoring or a spice. The spice extract can be used in pharmaceuticals like antibacterial or antimicrobial, and also like a dietary supplement and energy drinks. And essential oil of the plant is used in body care, like in soap, shampoo, and aromatherapy, and so on. To finish our today's presentation about essential oils, I would like to give some information about main plant families and their representative containing essential oils. So first, it is the Apiaceae family. And members of this family, the first one is anise. Pimpinella anisum is a Latin name. Anise grows wild in the Near East and widely cultivated among other places. The leaves are cordiform at the base and trifid at the top with linear divisions. And the leaves in between are compound with dentate lobes. The drug is a fruit which is diachene, ovoid or puriform, and yellowish green. The mericarps attached by the apex to the end of the carpophore. For chemical composition, for active compounds, anise fruit contain 2 to 3% of essential oil. And also, fruit contains polysaccharides, lipids, flavonoids, and so on. The main component of essential oil, with 80 to 95% of concentration, is anethol, and alongside with methyl havicol, anisaldehyde, and other compounds. The fruit is identified by morphological examination and by the microscopic characteristic of the powder. Unicellular trichomes, can you see in the middle, down in the middle of the slide, unicellular trichomes with a blunt apex, sometimes curved, and with a warty cuticle, secretory duct fragments. We also perform a TLC analysis of the extract of dichloromethan extract, and the TLC can show us the presence of anethol and triglycerides. For pharmacological use, in fact, the estrogenic activity of this compound of anethol was described, and anise oil must contain 84 to 93% of anethol. So it has a digestive, carminative, and antispasmodic actions, and the infusion of leaves can be used in medicine, and essential oil is used in beverages. But we have to pay attention that anethol is toxic for central nervous system. Next representative of Apiaceae family is the fennel. Fennel is Latin name of the fennel is Phoenicum vulgare. It's a tall perennial herb. It's easy to identify by its feathery leaves, divided into thread-like segments. Its umbels are greenish yellow, and with characteristic odor. The species grow wild in Mediterranean area and is cultivated in lots of countries. The fruits are collected as soon as they turn yellow. The fruit is of sweet fennel is diachene, almost cylindrical and surmounted by a large stellopod. The mericarps are often free and have prominent ribs. The drug smells strongly like anise and has a penetrating and sweet taste. Sweet fennel oil normally contains 80% and more of anethol, 1 to 5% of methyl havicol, and less than 5% of phenhone. Fennel fruits also contain furocumarins, including imperatorin, bergaptan, and xanthotoxol. Bitter fennel oil contains 50 to 80% of anethol, 3 to 20 methyl havicol, and up to 24 of phenhone. The drug is identified by macro and microscopic examination and by TLC analysis of dichloromethan extract. So, for uses of this drug, fennel is an industrial source of anethol. In phytotherapy, the sweet fennel fruit may claim the same indication as the fruit of star anise or anise seed, traditionally used for symptomatic treatment of gastrointestinal disturbances such as epigastric bloating, impaired digestion, flatulence, and others, functional dyspepsia and others. The sale of essential oil is subjected to the same restriction. Fennel root is traditionally used to enhance urinary and digestive elimination functions. Coriander, Coriandrum sativum, the plant material is also the fruit. The coriander fruit is globose, 5 millimeter in diameter. Its mericarps are not split. They are surmounted by the calyx teeth and by a conical style put. The primary ribs are not very prominent. The dried fruit contains not less than 3 milliliter by kilogram of an essential oil, but the fresh fruit contain up to 14 milliliter by kilogram of essential oil with main compound linalool, and alongside with camphor, geranyl acetate, gamma terpenen, and the others. Reputed to be antispasmodic, the fruit is mostly highly prized spice. It's used in bakery, in curries, in liquors, in beverages, and the fruit is used like a spice. Of course, it's sold like a spice. This is the microscopic examination of coriander fruit. So the next family of plants containing essential oils is Laminaceae, with lavender like the first representative, Lavandula angustifolia. The flower of these plants are used to obtain the essential oil. The main compounds are of essential oil, which is the concentration of which is 0.5 to 0.8%. The main compound is linalool, linallyl ester, cineol, and camphor. So, true lavender is a shrub growing in the low mountains of the Mediterranean area. It has silvery green leaves that are very narrow and are curled on the edges, and flowers grouped in biparous cymes on short peduncles. The calyx is bluish gray and the corolla bilobate with the upper lip bifid, and the flower is trilobate and is of blue color. The pulverized drug is characterized by numerous bifurcate covering trichomes divided once or several times. The dried flower has not undergone any pharmacological experiments in animals. In vitro, lavender oil has moderate antibacterial activity. Perose, and in the mouse, it has a antidepressant activity. The drug may be used in the composition of phytomedicines with the following indications. Topically, traditionally used to treat minor wounds after thorough cleansing, for sunburns, superficial burns or of limited area, and diaper rash, to relieve nasal congestion in the common cold, and as a mouthwash for oral hygiene. Orally, it is traditionally used to treat the symptoms of neurotonic disorders in adults and children, especially in case of minor sleeplessness. If the phytomedicines are total drug powders, hydroalcoholic extracts, or alcoholic titer, or tinctures, they must, like the sage, pass safety tests. The composition of the essential oil varies depending on many factors, particularly the mode of cultivation and the environmental conditions. To fulfill the requirements of the pharmacopoeia, lavender oil must contain 25 to 38% of linalool, 25 to 45 linallyl acetate, 0.1 to 0.5% of limonin, and up to 1.5% of cineol. The next representative of this family is, of course, peppermint. Mentha piperita, an extremely hardly perennial plant that propagates by stolons. Peppermint is characterized by quadrangular stems, most often purplish, by entire opposite decussate leaves which are ovate, acuminate, and denate, and by inflorescence composed of slightly bilobate purple flowers grouped into very tight spikes. Different varieties are cultivated of mint, and drug identification is easy. Characteristic odor: leaf plate, acuminate, serrate, asymmetric. Lateral veins are at 45 angle and principal vein prominent on the underside. Under the microscope, the drug has glandular trichomes with unicellular stalks and with heads comprising either one cell or else 8 radiating cells. In the latter case, the head is swollen and oval, and the essential oil accumulates under its cuticle. The peppermint leaf contains many compounds: triterpenes, carotenoids, phenolic acids, and flavonoids. The latter are represented by lipophilic polysubstitute flavones, aglycons, and by particularly abundant flavone and flavonoglycosides. Over 17% in some clones, always with eriocytrine as the major compound. The essential oil represents from 10 to 30 milliliter by kilogram of the weight of the dried drug. Its composition varies as a function of multiple factors, intrinsic and extrinsic, including the cultivation conditions, climatic variation, and harvest time. The chief constituents always is menthol with 30 to 40%. It occurs alongside with menthone, methyl acetate, menthofuran, is isomenthone, pulegon, neomenthol, piperitone, and other compounds. The use, it's widely used. You can see the crystallic menthol here on the slide, and the essential oil and menthol itself is widely used like a mouthwash and emollient. So the next family of the plants containing essential oil that we will cover today is Myrtaceae family, and with the representatives like eucalyptus. We will cover today eucalyptus and Syzygium aromatica. So, Eucalyptus globulus is the Latin name for eucalyptus. It is the very large tree with a trunk that exfoliates into long shreds, and its leaves are characterized by striking dimorphism. The leaves on the young shoots are opposite, sessile with a rounded blade, waxy and bluish green. The leaves on older branches are dangling, alternate, shortly petiolate with a synth-shaped blade, coriaceous and grayish green. The flower bud has 4 rough and waxy sepals fused into 4-sided lead-formed, and numerous stamens reappear. The species grow wild in Australia and has been introduced in many other areas, including Azerbaijan. The essential oil concentration ranges from 5 to 35 milliliter by kilogram. The major constituent with 70 to 80% of concentration is cineol or eucalyptol. The other constituents are chiefly terpenoids. The leaf also comprises a dozen oxygenated heterocycles with a mono or sesquiterpenoid structure, including acylofluoroglucinol moiety, the euglobules, and macrocarpals, as well as phenolics and the flavonoids. The tests include quantitation of the essential oil, TLC analysis, verification the absence of citronella and foreign elements. The assay of essential oil is conventional and includes refractive index, specific gravity, optical rotation, and other. Eucalyptus oil has antiseptic properties which have been established unambiguously in vitro on many germs. Cineol is readily absorbed by the digestive route as well as by the cutaneous or rectal route, and is eliminated by pulmonary or renal excretion. It is widely accepted that eucalyptus oil has expectorant and mucolytic properties and stimulates the bronchial epithelium. Eucalyptus oil, like menthol, is believed to decongest the upper respiratory tract in case of common cold. Despite the absence of clinical trials to demonstrate the undeniable therapeutical interest of eucalyptus oil and cineol, both products are ingredients of many proprietary drugs because of their antiseptic and decongestant activity. You can find them in syrups, nasal drops, and preparation for inhalations, and so on. Phytopharmaceuticals based on eucalyptus leaves are traditionally used to treat acute benign bronchial disease and to relieve nasal congestion in the common cold. And to finish with this family and with the plants containing essential oils, I would like to say some words about Syzygium aromaticum, or the clove. The plant, the tree bears not deciduous leaves. The flowers are tetramerous, pinkish white, and grouped in small, compact, and ramified cymes. This tree originates from Molucca Islands. Cloves are traditionally cultivated in Tanzania, in Madagascar, and in areas of Indonesia that have kept expanding over the last 30 years. Although the Indonesian production is essentially consumed locally, the world production is such the price of the drug has decreased considerably in late 1980s. The floral peduncles, clove stalks, are separated and directed toward distillation. Although the flower buds are used in part for the obtention of oil, the leaves are the main source of oil. The drug is very easy to identify: characteristic aromatic odor, pungent taste, and typical morphology. As suggested by a French name clove nail, clou de girofle, the flower buds is shaped roughly like a nail. It has a granular part called hypanthium, which correspond to the inferior ovary and globulous head, surrounded by the four divergent lobes of the sepals and consisting of four imbricated petals wrapped around the numerous incurved stamens. The pulverized drug is characterized by fragments of parenchyma containing large secretory cavities, cluster crystals of calcium oxalate, and many triangular pollen grains, and short fibers with thick, lignified, and slightly punctate walls. Only clove oil has been the focus of attention. It occurs in exceptionally high concentration, 150 to 180 milliliter by kilogram, in some specimens. Its composition is characterized by propenyl phenol, which is by far the major constituent, and also eugenol. So clove-based phytomedicines may be used locally for the following indication: to treat minor wounds after thorough cleansing, as an analgesic in headaches, toothaches, etc., as an analgesic in disease of the mouth, pharynx, or both, in a mouthwashes for oral hygiene. Internally, cloves are traditionally used to treat the symptoms of gastrointestinal problems such as epigastric bloating, impaired digestion, and flatulence. So this is what I wanted to tell you about the plants containing essential oils. So this is the end of our lecture for today, and I thank you for your attention. Have a good time.